I'm Anil Kumar. Welcome to my series on vectors. We're looking to intersection of planes in this particular video. The question here is, solve the following system of equations, state the solution, and classify the system as consistent, inconsistent, dependent, and or independent. So we are given three equations of the plane. This is lowercase x. So we'll actually use the method of matrix, the Gaussian method, to find the solution. So let me write down the augmented matrix from here. So we could write this as, we'll take the coefficients 2, minus 3, 1. Here we have 2, 1, minus 1. Then we have 1, minus 1, minus 1. And the values minus 2, 4, and 1. The idea is to get zeros in these three places. So in the first step, let us see how to get 0 in these two places. So what we can do here is, okay, so I will actually modify this. Since this is the simplest form, I'll rather keep it on the top. So we'll just switch the positions. So we can actually modify this. We can take this to the top. It doesn't really matter which equation we write first, right? So, and that's an important step to simplify. So I'm taking this on the top and then rearranging. So we get 2, minus 3, 1, 2, 1, minus 1. And we took this on the top and then we shifted. Okay. So that makes things simpler. Since we are always multiplying the very first one, keeping it kind of same, and trying to get the 0. Now, if I perform the operation that in row 2, I take away twice row 1, then I make this 0. And here also, if I do the same thing, I can make this also as 0, right? So row 3 minus 2 row 1 will give me a 0 here. So performing these operations, I could actually rewrite my matrix as, so first row let me copy as such, 1 minus 1 minus 1, right? And we have 1 here. Now, if I do 2 times and take away, then that becomes 0, which we want. And this is 2 times, so it becomes minus 2. When you take away, it becomes plus 2. You get minus 1 here. 2 times is minus 2. Minus 2, when you take away, it adds to 2. 2 times is 2. And when you minus 2 will make it minus 4. Okay. The last one here, multiplying this by 2, then taking away will make it 0. Minus 2 will make it 3. And minus 2 will make this as plus 1. Minus 2, when you take away, it adds to 6, right? So that is what we are going to get, right? Okay. Let's re-look into it. So when I multiplied by 2, I got these equations as 2, minus 2, minus 2, and 2, right? So I'm taking away from here, so it becomes 0, that becomes minus 1, this becomes 3, okay. This becomes 3. And when I do this, minus, it becomes minus 4, that's correct. Here I do 0, 3, and that becomes plus 1, that's correct. And 4 minus 2 will be 2. Correct. So I think this is better. So it's better to write and then do it. Okay. Now, so we got these two zeros. Now the idea is to get a 0 here, which we can get from the second row. So what operation should I perform on this? Now I'm writing here. Sometimes we write in the new matrix. So what we are doing here now is in R3, from R3, we are taking away, we are adding 3 times R2. So we get a 0 here, right? So that's what we will do. So if I do that, in that case, what happens? So the first row is 1 minus 1 minus 1, 1. Okay. This also remains same, 0 minus 1, 3, minus 4. And here, I'll multiply this by 3 times and then add to this. Okay, so that becomes 0. Okay. 3 times 3 is 9. When you add, you get 10. Minus 12. When you add, you get minus 10. That's what you get. Okay. So from here, we can get the values of x, y, and z. Correct? Right. So you could write here that you get from here, this gives you, this statement itself gives you 10z equals to minus 10. So z equals to minus 1. Correct. Perfect. So we get the value of z. Now, let's look into the second equation, which is this one, right? So that gives you minus x plus 3, sorry, y, so sorry, minus y plus 3z equals to minus 4. We know z is equal to minus 1, so substitute there. Minus y plus 3 times minus 1 equals to minus 4, and that gives you y as equal. We'll take y to this side, 4 on this side, so 4 minus 3, which is 1. So we get the y value is 1. Okay. Now let's find the x value. So the x value is x minus y minus z equals to 1. So x equals 2, y is minus 1, z is minus 1, that makes it plus 1 equals to 1. So x equals to 1. So we get the value of x, y, and z, and that is the point is, so they are intersecting at a point. So x is 1, y is 1, and z is minus 1. So basically, this intersection of these three planes is at a point. It could be thought of like this, right? So that is the point which is 1, 1, and minus 1, where they intersect, right? So that is how we can find the point of intersection for the given set. Now, the idea here is to answer whether the system is consistent, inconsistent, dependent, or independent. So our answer is, since we have a solution, it is consistent, right? And since we have a point, a fixed point, it is independent. So that is important to understand. So we have a consistent system here. So we'll answer this as consistent and independent. Since we have a point of intersection. It becomes inconsistent if there is no solution for the intersection of planes, and becomes dependent if there are infinite solutions. That is, intersection is a part of a plane itself, or it's a line, right? In that case, it will be dependent. So at present, it is consistent and independent. So I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that would be great. Thanks for watching and all the best.